Hello. So today going to cover Kubernetes the hard way. If you saw the beginning of if you saw the Hello World tutorial or stream last time, excuse me, you know that I am doing this from a Mac. So let me show some code, or not some code, but a drawing here. So this is the current setup we have. I have a virtual machine using VirtualBox and Vagrant on a Mac Mini. I'm going to be setting up Lexi and LexD to run the Kubernetes cluster inside. I am connecting from the MacBook because that's where the OBS Studio is running, which is what streams, and that uses a lot of resources, and to prevent issues with the stream, that's the reasoning there. I am on the Mac Mini here. If we look at the Vagrant file, you can see that it's an Ubuntu 18 installation. There are 3 ports that are forwarded: AD443 and 8443, which is the Lexi, so that I can connect to Lexi from outside of the Vagrant machine. What else? We have 6 gig of memory in use and 50 gig of disk space. Vagrant status. It is already running. So if we connect with Vagrant, this is SSH. Okay, so cat / etc. star release star. We can see this is our 1804. We are on the Vagrant box as Vagrant. There are no currently running boxes or containers. So first thing we want to do is initialize the daemon for the Linux containers using LXD init. Would we like to use LXD clustering? So what that would enable is to add multiple devices. So if I wanted to add my laptop as LXD, I'm actually not sure what the terminology is, but a host, then by running LXC containers, it would enable them to run on whichever resource is most available. So either the laptop or the Mac Mini. In this case, I'm not going to be using that. So maybe at some point in the future, we can dive deeper into that, but let's just say no. New storage pool, yes. Default. So the types are LVM. Actually, let's look at that. Let's look at do we have, what's it, BT BTRFS. Yeah, so directory, I suppose, backed on any backing file system. BTRFS backend, if the host is BTRFS, ZFS. So it's just the same way that you would have EXT or ZFS. It's just the default. So we're going to go ahead and go with that. We need to make sure that we have a large enough pool size if we're using that, because currently resizing is not really possible. So create a new BTRFS pool, yes. We do not have an existing block device. We have 50 gig, so let's use 40 of that. And no, do not want to connect to that. Get a local storage network, yes. Default's fine. All these are fine as defaults for what we're doing. But this, we do want to say yes, just so that we can access it from either the mini or the laptop. All ports. See, that's the 8443 port that we forwarded from Vagrant. Adding a password. Sure. We can print it. I don't know that it's all that useful. Let's see here. LXC list. LXC. Just, we want to run a Ubuntu not right now. I can't remember the syntax for launching. It's very simple. So LXC launch Ubuntu 1804. So it is the first time it's run, so it's got to download it. From here on the right hand panel, this is the laptop. If I do an LXC remote list, we have a VirtualBox connection and a Mac Mini connection. So if we do LXC list, right, because this is an old version of the remote. So I need to do a LXC remote remove. And just the remote's name. Let's see. We first have to change the default connection away from the existing one. I guess we could actually do an LXC remote add and nope, that is not right. So we'll do don't have it handy. Grab that IP address here. Remote add. Just call it mini. Okay, so now we want to do a LXC, what is that called? LXC, is it remote? Switch to mini, and then I believe there's a remote default. list, switch the default. It's switch. Oh, we just did that. So we should be able to LXC remote delete Mac Mini. Hell, if you type things properly. LXC remote remove Mac Mini. So now if we do a LXC remote list, it's a little tighter so we can see that we have Mini, but that Mac Mini one is gone. So now if I do an LXC list, we can see from the laptop the Obling Ferret, which was just started over here. This is an IP address attached to that local bridge that we were asked about and is not accessible from this machine as far as I am aware. I don't know if ICMP is enabled by default anyway. So we can do, let's LXC exec so I am on the MacBook connecting to an LXC container inside of a virtual box spun up by Vagrant on the Mac Mini. That is a lot of stuff just to get us ready. We're going to create all of the nodes and elements and workers and all the things required to do the Kubernetes from scratch on the LXC containers instead of the cloud, just partially for interest and partially to avoid accidentally leaving it on and burning through credits or anything like that. So don't know for sure if it's going to work, but it sounded interesting. So if we cat / etc star release star, this is still in 1804, but this is inside of the LXC container. If we look at mount or not mount, df-h / you can see this is a loopback device that is approximately 40 gig, which is what we allowed. If we look at here, we've got the Vagrant, which is a little over 60 gig. So although that is interesting because we told the Vagrant file to give us 50 gig and it has 56 available. Maybe it's because it's human readable and the calculation of 50 times 1000 versus 50 times 1024. Who knows? Numbers are strange. So Vagrant SSH again. So I could run this all from within the local machine here that I am streaming from, but let's just go ahead and do it from within Vagrant just to avoid any additional network hops. For now anyway. So what we need is Kubernetes the Hard Way. Okay, this is the tutorial by Kelsey Hightower, who is amazing. Anyone interested in Kubernetes definitely needs to learn more about Kelsey and his talks. But let's dive right in. So I guess we want to look at the docs and prerequisites. So here is how you can get set up with the cloud on GCP. Like I said, decided to do this with Lexi, installing the client tools. So this is to install a couple of tools used for creating the certificates. That's at least the first time I started to go through this and decided to, well, actually I didn't decide to stop. I ran out of space on the Lexi device and got to where I was starting to work with the workers and ran out of space. So I thought I had been planning to do that and planning to start streaming and recording videos for YouTube as well, and decided I would just do it all together. So best I can remember, we want to grab these tools. We're already on the Vagrant machine. Let's go ahead and create a tmux session here. So the black line down here is my local tmux session. The green line is the Vagrant machine. So let's do a Control B, set status right to Vagrant. Okay. So we add in wget. So quietly show the progress, HTTPS only, getting the CFSSL and CFSSL JSON tools for creating certificates. That seems to be the most difficult part, is the certificates, which is the case everywhere, always. Certificates are hard. They were much harder before Let's Encrypt. But let's see, I'm going to open up the new VS Code window, because there are some things we're going to need to copy and paste to update. I have lost my window. There we go. Okay. All right. Okay, so we added the tools. Now we need to make them executable and move them to the appropriate locations. So +X makes them executable, moving them to user local bins so that we can access them without adding the // in front of it. Let's see, so now let's check out our version. So we do have this version. 1.4.1, which is what's expected. This is definitely a bit of an older version of Kubernetes, I believe, based on the tutorial 1.18.6. Let's just check and see what the current, 1.20 is the current Kubernetes version. So it's not as far out of date as I was thinking, but it's a little bit back. So the JSON version, same. So now we're going to grab the tool that has a name that no one is 100% in agreement on. Kubectl, kube control, and I guess Kubernetes kube control. There's no R, so kubectl is, I assume, the best version of it. I don't know. No need to get in an argument like other things, GIF, JSON, etc. Okay, now we've made kubectl executable, and we want to move that to user local bin. So now we're gonna, oh crap, well, I was not paying attention and installed the OS X version. That would have caused us some hassles. So let's grab this. So it's getting kubectl executable, moved it to user local bin. All right, so let's check out the version. Nifty trick is you can use -- short to get something that is human readable. Or I guess alternatively, you could use, oh no, that's not actually full JSON, is it? No. So I was going to suggest trying something like Python module JSON.tool. It's not a JSON object, but if we, well, actually it's not JSON at all, because that's not valid either. Okay, so just the -- short makes it much more readable. All right, so next we're going to provisioning compute resources. We don't need to do that. That's what the Lexi setup was for. Let's just make sure that there's nothing here at the end. No, so we should be good to provisioning a CA and generating a TLS certificate. Let's just check our, yes, we have a /vagrant. That should be the directory with our vagrant file. Excellent. So let's make dir, well, I don't know what that word is. Make dir, Kate's Hard Way. Cool. So what we have is generating the certificate authority. So this entire block is a bit of a function. I don't know. It encapsulates the entirety of the command. I've not seen it before. It's pretty interesting. So, this is a command that is taking the content between the EOFs and shoving it into this file called ca-config.json. So we're catting into it what comes from the end. Then doing the same to this csr.json. And then using that cfssl generate gensert knit ca. So we're basically creating the ca key and the ca both .pem files. And let's just make sure that there's nothing that we need to update, because there are some of these that we will need to change because they're defaulting to the GCP setup, but what we are doing is local. Okay. Yeah, obviously this is not correct, but it doesn't matter. This isn't a public server, this is a toy. So we paste that in, enter. Oh, this one is L. We have a JSON, CSR, and the 2 PEM files. Okay, so that was creating the certificate authority. Now we are going to generate the admin certificate. So let's look through here. Those all look acceptable for our installation. Yep. So alias L equals LTHR. That is long, by time, human readable, and reversed. So that gives us files in reverse order. So we can see that the admin files are here at the bottom. That just makes it nice and easy to see what's being updated. And human readable just gives us the kilobytes, megabytes, gigabytes, terabytes, I suppose. I've not really seen a terabyte file. I mean, on a local machine. Okay, so kubelet client certificates. What do we have here? So let's just have a look at this here. And we want to change this to a shell script. Okay. Our external IPs. Okay, of course we need to create some devices. We created that one. So let's just come over here. LXC list. We have this one. Let's go ahead and delete that. LXC. Delete. Well, I guess we can LXC stop. The reason I'm going to delete it is that we want to name it something of value. Okay, so LXC launch? Was that what we wanted? Yes. I just want to give it a name, image, remote name. Okay. So launch Ubuntu 18.04, and its name is going to be Nginx. No, we need HA proxy. So we'll need an HA proxy to be able to proxy to the different server, the different Kubernetes nodes in the cluster and workers. Okay. So what we are going to do here, LXC list. Come back and set up the proxy in a minute. We want to do an let's see, I guess our controllers. Let's just make sure we get the same. Well, we can go ahead and grab those. So worker 0, worker 1, worker 2. Worker 0, worker 1, worker 2. And I think they are called controllers in this. I just want to make sure that we don't get confused. Yes, there we go. So controller 0, 1, and 2. Wait, do we have worker 1, 2, and 3 and controller 0? No, 0, 1, and 2. 0, 1, and 2. Okay. Controller 0. Controller 1. And controller 2. So let's see, LXC list. All right, let's just grab this for a second. Come over here to our file. We've actually completely used that. We don't need that. So let's stick this up here. And we want to grab these. Yeah, it's fine. Okay, let's get this here. Okay. And just make those uppercase. I'll go ahead and add a export in front as well. Nope, need to actually, I think the equals needs to not even be there. So I think this is what we want. Cool. So now if we echo $, worker 0, 1, 2. Nice. Happy with that. And let's go ahead and do the same on this terminal session. Sweet. So come back up here. We created the admin cert. So let's just look at what we've got. Yes, the admin certs. And key, the admin certificate and key. The client certificates. So here we go. This we want to grab. Come over here. Looks a little small. Let's make it, well, can't make it too much bigger because we want to be able to see it all. For worker 0, 1, 2, we're going to create the files. The external IP is going to be HA proxy. That's what we're calling it, right? Yep. So that is our external IP address. That's how we'll be able to access this. Then our internal IP is going to be let's see here. I think I might be about to make a minor mistake and we want to avoid that. Okay, let me check this over here. Go back to... So I am looking at some of the notes I made before when I was trying to execute this. And see if I can find... I know there's something... no, that's not what I wanted. Let's see. All right. Just 1 second. So we need to I guess let's try this. Let's go with LXC list. So the 80. So I guess that is our external. Right, I think so. So our external IP is here, and our internal is here. I believe this is right. So, worst case, we'll have to do this again, and we'll see. So let's grab this updated script. So external IP address is the local vagrant machine. Internal IP address is the HA proxy, which is going to proxy to our controllers. Okay. So that should create the 3 files with the proper settings for the client certificates. Okay, and if we list these guys out, we have the JSON, PIMs, and CSRs. Cool. All right, now we need to create the controller manager client certificate. Let's see, is there anything here that needs to be updated? These all look very static, so let's grab that. This creating the Kube controller manager key and the certificate. Okay. Go. There's the fort. Now the kube proxy client certificate. What do we have here? Anything that needs changed? Nope, those all look good. Nothing that is referencing GCP. So since we are using Lexi containers, there's our kube proxy. The scheduler client certificate, again, all looks good. Scheduler stuff. Okay. All right. So what do we need from here? So this is all grabbing elements from the Google Cloud, as you can see here. Let's see. Host names looks good because those are all not specific to Google Cloud. The CSR JSON all looks fine. Nothing there needs changed. But now we want to generate the certificate, and this is referencing the public address. I believe what we want from here we want this. I think we want, so I believe these 10 addresses are the addresses of the Kubernetes hosts, or the controllers and workers, or it's the Kubernetes networking addresses. We want, so that was just asking for the public address, which is, I want to say the one we used before, which is just the external IP address. Or no, that's going to be HA proxy. Think about this a second. Let's go ahead and add the Vagrant Box's IP address and the internal HA proxy address. This is, since this is a test environment and not a production environment, I think we're okay. If this were a production environment, I would definitely be doing more research and not just making assumptions. So the majority of Kubernetes installations I've used are, spun up by providers, so they're managed instances, AKS being the major one. I've also used EKS and ACS, so offerings from Azure and AWS. All right, so we created these 3 files based on this Kubernetes CSR. Okay, service account pair. Yep, that looks good. All right, now we need to copy the files. So let's just grab this. LXC. There is an LXC copy. LXC list. So LXC copy, and we are copying CAPIM, CAPIM, keypim to the instance, and I don't think you use colon for this. Semicolon done. Let's just see. So this is only echoing it. So let's do an LXC copy. Remote colon destination. Yeah, so it is colon. So let's just do colon/root. So we are copying LXC copying CA worker 0 to worker 0's root, and so on. Echo. So this should. Did it right? Oh no, did it wrong. Oh, excuse me. That'll wake you up. Aye. Let's see. Let's try this again. Yeah. Okay. LXC copy. ca.pim. Let's just copy that to worker 0 colon/root. Worker. Did I misspell worker? Worker 0. Oh. It's because it's not on a remote, it's local. Okay, so then what's the copy source destination? Copy the file to destination. Let's see copy. Definitely doing something just silly. Let's just find out. Oh, okay. Push. That's what I'm... So, push file to container /root. All right, let's try copy that way. Error not found. That's nice. What am I doing wrong here? Oh, file push. Okay, so I'm a bit new to LXD, as you could tell, but the Docker networking seemed way too tricky to be able to try to run Kubernetes inside of Docker. I think it's possible, but for the hard way, I didn't think it made any sense at all, and don't have enough resources locally to run 7 virtual machines without bogging everything down. So we want to do an LXC exec worker -0 ls/root. Should see the PIM. Cool. Okay, so it is file push. So we go back up to our for loop. File push. So for instance, in worker 0, worker 1, worker 2, do LXC file push CA worker, the relevant worker's key, the relevant worker's PIM to the relevant worker's root. Okay, so 3 files ran. So let's go over here. Let's name this. Well, actually, let's just go here and let's make a set sync LXC exec worker dash 2 1 0. Oops. Okay, so these 3 panes in tmux are synchronized. Worker 0, worker 1, worker 2. So if we, I need to tell it what we're running. Bash. We don't need the A, just L. So our 3 files have been copied to the relevant workers. Excellent. Is this generating Kubernetes configuration files for authenticate? Oh wait, I think I missed something. So for the controller, we need to do the same thing. So this is workers. Do LXC file push, and we are pushing CA PIM, key PIM, Kubernetes key, Kubernetes PIM, service account PIM, instance /root /. So file push CA key, Kubernetes service account key, service account to the instance /root. So we should see the 3 copies happen. So now if we create a new window and we name this controllers and open up 3 panes, then sync them, LXC exec controller dash No, 2. 1. 0. Did it again. 0. Okay, so we've got ls -l. We've got the files. Awesome. All right. Let's see, how much is in this file? So I've only got about 5 more minutes left. I don't think I'm going to continue on today, but I should be back on at the same time tomorrow. I hope that was interesting. I hope you got some value from it, and I'd love to hear from you. I assume, since there's nobody here at the moment, that mostly I'll be talking to anybody watching the VOD, either over the next couple of weeks on Twitch or on the YouTube channel. So don't forget that to follow if you want to continue on this series and find out how it goes, whether that actually works or if it's a giant fail. Thanks. Bye.